Early on in 6.1, we talked about polynomials and we named them. And part of the name came based on the degree. Now that degree also determines what the graph is shaped like. So we're going to look at those graphs. Now a parent function is like the original graph before anything is added or subtracted to it. Those parent functions don't always look exactly like you would see most examples. So I'm going to show you the parent function and another example for these. Okay? So the first one we talked about was a constant. And a constant is when the degree is 0. So there's no x at all. So it's really like y equals some number. It could be any number. So I'm going to put c for constant. And the graph of that is just a horizontal line that crosses through whatever number. So if it's y equals 2, it would be a horizontal line that crossed through 2. So that's the number c, whatever number that is. It could be anything. Well, that one's pretty simple. The next one we talked about was linear. That's when the degree is 1. So like y equals x to the first power. You don't really need that one. So the parent function, nothing else is added. It's just x. Let's look at the graph. Y equals x. So that's the original parent function. But it could look a little different, right? You've seen straight lines. It could look something like this. That's still linear. This one has a negative slope because it's slanted down. The next one, quadratic, that's y equals x to the second. So a degree of 2 is a quadratic. So the parent function looks like this. This is the original. You've seen that shape before. We spent all of Unit 5 talking about that.
It's a parabola.
It is a parabola. Good. You remembered something. But it could look a lot of different ways. It could look something like this. It could be upside down. The next one is cubic. So y equals x cubed. So that's the original with nothing else added or subtracted. And it looks like that. I don't think it has a name like parabola. If it does, I don't know it. And yeah, sometimes they will look like that. But usually they've got like bigger humps, I guess. I don't know. They're a little more defined there in the middle. Not always, but you'll see it more like that. The next one is y equals x to the 4th. Quartic is a degree of 4. Now, if I were to graph the parent function, it actually looks a whole lot like the quadratic. It's a little more flat in the bottom. Okay. But you're not normally going to see a quartic like that. You're usually going to see it more like this. Again, you've got some steeper ups and downs there in the middle. And the last one is quintic, y equals x to the 5th. That one looks a whole lot like the cubic, but a little more flat. In the center. But just like all the others, the parent function, you're not normally going to see it like that. It's going to be more like this. So what we're really going to focus on today is something called turning points. And this requires no formulas. It only requires you to push a few buttons in your calculator. So I'm going to sketch out that might be a graph that you see. And a turning point is where the polynomial, where the graph changes direction. So for example, if I were to put my finger on the far left and trace, I'm going uphill at first, but then I change and I go downhill. This point at the very top is a turning point. It went from going uphill to downhill. I change and I start going uphill. But then I get to the top and I change and I go downhill. Okay. So each of those like peaks at the very top and those valleys down at the bottom, those are turning points. If that point is higher up, I like to say it's on the mountaintop, the hilltop, we call that a maximum. You can just put max. Yeah, we did this in quadratics. How many hilltops or maximums does this picture have? 2. It has one here, and it has one right here. Okay. Those 2 are maximums. If it's a lower point, like a valley, we call that, what do you think? Minimum, min. How many minimums do I have? Just this one right here. And these points are going to be essential for the next little thing that we do, called increasing and decreasing. So here is how you find those maximums and minimums on the calculator. Step 1. We're going to graph the function. So you got to hit y equals and type it in. So you go to your y equals and type this function in, and then you hit graph. And it will graph it for you. So once you've looked at the graph, you're going to hit the trace button. And that's going to put your cursor right on the line. And so you can use your left and right arrows to go along your graph. Now, doing it this way, you're not going to get the perfect exact maximum and minimum, but I don't really care. This is pretty close. So I'm going to trace until I get to this mountaintop. Now, when I click left and right, they're really close together, notice. Okay. So if you don't get on the exact one that I do, that's okay, as long as you're fairly close. If you're 5 or 6 clicks away, if you go right here and say that that's a maximum, no. But if you're at any of these right here at the top, that's okay. A way to be more sure, if you want to get it right, if you look at the y values, if I want a maximum, I want the biggest number. And so this one with the 4.29, that's the highest. Okay, so that's the one I'm going to pick. So I have a maximum, and my point, we're going to do a coordinate, 0. I'd rather you round to 2 decimal places instead of 1. So this would be 76, comma, and then my y value 4.29. If you put 0.75, it's okay. But if you have like 1.3, no.
That's crazy.
Okay, you should be close. All right, then I'm going to trace, hit my right arrow, and go down. Yep, to the minimum. So right here it is. The minimum, the closest minimum is 3.33, comma, negative 4. That would technically go up to 30. If you put 4.29, it's okay. But you shouldn't have like negative 6. Okay, that's way off. Anybody not getting these numbers, getting this graph? So we're going to do a few examples. We will not, there's 6. We won't do all 6. But we are going to graph them. Now I do apologize because they didn't copy well. The graphs didn't. So, and when you're graphing decimals, you're not going to be perfect. Okay, we'll get as close as we can. So number 1, go back to your y equals and clear out the one that's there. And then we're going to type in negative x cubed do what?
This.
Oh, have you already graphed it? Okay. Minus 4x squared minus 4x minus 1. So I typed that into the y equals and hit the graph button. Make sure that yours looks like mine. Once you have it graphed, Then you can hit the trace button.
Come on, man.
I prefer to do left to right. It doesn't matter which one you write down first. But this one is a minimum. So it's the valleys and hills aren't as steep on this one. That's okay. It's still a little bit of a valley. So my minimum is negative 1.97, comma. That's okay.
On my minimum is 2.12.
That's because I was one click over from you.
Okay.
That would have been okay. And so when I graph this, I'm pretty much going to go left 2 and then down 1. Again, your points do not have to be perfect, but you do need to get a point fairly close. And I'm going to go ahead and label that negative 1.97, negative 1.
You said we need to label the points?
Yeah. And I do want you to put this on the graph because the next thing that we do, not today, but it's very beneficial to have the points, the coordinates labeled, so you don't have to go back up here and think, okay, which one was this? It's just easier that way. Then I'm going to trace over to my maximum. And my maximum is negative 0.61, comma 0.18. So when I graph this one, I'm going to go left about halfway to the negative 1. Again, it's not going to be perfect, but don't go past negative 1. And then I'm barely going to go up just a little bit. And now I'm going to look at the picture of my graph, and I'm going to try to trace, or not trace, I'm going to try to draw that the best I can. I have found that it's a lot easier to kind of work around these points first and get your hills and valleys, and then extend the lines. Like, don't start up here and then like work around the middle first. Let's go on to number 2. I'm going to go back to my y equals and clear out the last one. And type in x to the 4th minus 3x squared minus 2. And hit graph. Then I'm going to hit the trace button so that I can trace along my lines. So my first minimum, that's the one I went to first, is negative 1.21, negative 4.25. So I'm going to go to the negative 1 and a little bit more. I'm going to go down 4 and a little bit more. And I'm going to go over to this maximum, this hilltop, which is at 0, negative 2. That one is on a perfect point. That does not happen that often. Zero, negative 2. And then go back over to the other minimum, which is at a positive 1.21, negative 4.25. So that one, right there. Oh, and I forgot this.
Are there two different minimums?
There's two different valleys.
Oh.
And then I'm going to sketch this one. Made that one a little crooked. Should have been over here. Any questions? All right, we're just going to do two more. We're going to do numbers 3 and 5. So number 3, go to your y equals and type in negative x to the third. Remember to go outside of the exponent before you keep typing. Plus 3x squared minus 1.
X to the third.
I'm going to hit the trace button. Now I put it on what I think is the minimum, but I still want to click a little bit both ways just to make sure it doesn't keep going down. And that is the minimum.
How come yours says x0 there? I don't want to say y as you, because my y is the same as yours, but my x.
If you see an E, you see an E in it?
Yeah.
That really means that it's 0.
That's weird.
Okay, yeah, because that was messing with me last
So let me give you a quick, this is scientific notation. So,
Bro, I don't even know what chemistry is.
alright, so if you see, you can't even really see that very good, e to the negative 10. That means you move the decimal place left 10 spots. So basically it's going to be like 0.000000000001345. Isn't that basically 0?
Yeah.
Yeah. So if you see an E with a negative number, that just means 0. Sometimes yours will say that, sometimes it'll actually have a 0. I don't know why the calculator can't just put 0. So 0, negative 1. And then I'm going to trace over. I'm going up, up, up. So that's the point, 1.97. And it's 2.997. I'm just going to put 3. You could put 2, 3, I guess. But this one does round to 0.97. That will just keep going up. So then I'm going to sketch my graph. Are there any questions? I want you to do number 5. Alright, here is number 5. Remember, your points may not be exact, because if you were 1 or 2 clicks in one direction, it might throw your numbers off a little bit, but as long as they're fairly close, as long as your graph looks about the same, you're good.